Hi, guys.
Hello.
Hi there. Hi, everybody. I hope you're excited. Today is the last bit of information for calculus. Not that you're not really enjoying it, right? You guys talk about it at parties and stuff. I have this great calculus class. It's so fun. All right, let me see everybody. Come on, guys. Thank you. Is Dylan here yet? Dylan, let's remember we have to talk after class, okay? Don't let me forget.
All right, sounds good.
Okay. All right, first thing I want to do is point out a little mistake that I made in last notes. I corrected it before I posted the notes. But can you guys get your notes out from last class? And thank you to those of you that turned in the extra credit assignment. Didn't you find it fascinating how it followed that logistical curve and at the inflection point, right at the end? And that's what all the news stations were waiting for, it to hit that inflection point, because that meant that it was no longer growing at the same rate, which is what calculus is all about, right? The different rates that things grow. So
I have a, oh, sorry.
Go ahead, Kev.
Um, did you just want us to like email that to you, or was there an inbox for it?
No, email is fine.
Oh, okay, cool.
Yeah, and I got it from probably half the people in the class, which was really nice. It was really nice, and I've read a few of them so far, not all of them, but you guys all had really interesting perspectives on it, and I want you to know that I'm interested in your COVID experience and what it's like to be a college student. So a lot of you guys went into that for me, and I really appreciate that. That's nice, including a little bit of personal info. Tom, did you have a question, hon?
Yeah, when is the extra credit going to be graded?
Well, I will tell you that I have printed them all out and I've been reading a little bit, but when will it be graded? I would think, what's today? Wednesday? I would think by Friday. Sound good? Yeah, I try and turn it around fairly quickly. All right. So, am I sharing my screen? Here's the error. It is on where you see, look at the page where example 4 is. And now I can't exactly remember what I did because I changed it right away. I saw it when always before I post notes, I look through it and make sure that everything is as it should be. But I was like, oh, dang it. And now I can't even remember exactly how I got it wrong, but I'm going to show you how it is correct. I'm just dragging you guys down so I can see everybody.
Could you post the notes that we're doing today on Moodle?
Yeah, I post the notes every day.
Like the ones that we're doing. I didn't see the ones you're doing.
Oh,
like
the blank ones on there, darn it.
Yeah, that's what I think. Yeah.
Yes, I can do that. We have a little extra time because we don't only have a few pages to do, like 6 pages total of notes. So we do have time to do that. So everybody go to their thing. Let me stop sharing. I got to go to a whole different browser. Loyola will only let me use Microsoft Edge, or I don't think it's Loyola. I think it's Baltimore County, since I'm using a Baltimore County computer, and since we got hacked, like it's really hard to get into all the other schools that I work for. I have to like open a private window. It's insane. So everybody go to your thing. You'll see it in a moment. And I have to go through this process to sign in. Oops, spelled my name wrong. You ever do that? All right, hang on, I gotta get my phone. Facial recognition and everything. It's crazy. What does this world come to? Okay. Oh, I see it. It's there. It's in April 19th to 23rd. It says 5.1 through 5.3 notes outline.
Yeah, but it's only 5.1.
Are you sure? All right, I'll add it. Thank you, Jadelle. Let's see. All right, 5.2 is there now, so go ahead and print that out and I'll also post 5.3. All right, so it's all up there. What time is it now? 3:08. Can you guys print it out real quick? Sorry I didn't get it to you sooner in case you wanted to print it out somewhere else. How's it going on campus, guys? Yeah, and what about COVID cases and stuff? Are they going down yet? Have you guys heard anything, any news about that? Like any news about certain buildings or certain residences being locked down? I haven't heard any news like that lately. So that's kind of like the inflection point, right? I'll give you a minute. Let's say we'll start again at 3:10. So if you guys need to go do something real quick, you can. All right, everybody all set? Okay, so let's see, let me get out of this. So you're going to go to example 4 on 5.1. Let me share my screen. And look what I made, guys. so that I would remember to share my screen. But then, you know, what's funny is today I put it on my screen, and then when I came up, my picture was green. I was like, I wonder why it's green. And then I look at this. I'm such a dork sometimes. All right. Okay. So here's example 4. And up here, I had something else written, I think. I don't even remember what I had, but I was like, wait a minute, that's not the change in t. The change in t has b minus a, right? So that, like, here's your b and here's your a. So you do b minus a and divide it by the number of intervals there are. And that's how you get change in t. I don't even know what I wrote, something different than that. So just make sure you correct your notes. I did correct it on the notes that I posted. So this stuff in green right here is what I corrected. All right, any questions on that? Okay, is everybody back? Jadelle, Thomas, Kevin, Richard, Drew, can I see your lovely faces, please?
For some reason, when I'm turning my camera on, it says internet connection unstable.
Okay, then don't do it because you'll lose me. But thank you for letting me know. I appreciate that. All right, so we're going to move on to 5.2. We're going to finish 5.2 and 5.3. There's only a couple of pages for each one. Is fairly simple stuff too, not too difficult at all. But what again, like I suggested the last time we met on Monday, is what I would suggest you do is it's not like brains, you know, it's not like really difficult or anything, but the homework will be so much easier for you to do if you do it right away, because it can be not confusing, but it can be sort of precise in what they're asking for. Okay, so definite integral. We sort of alluded to this in another lesson in 5.1, what the definite integral was, because remember I was telling you we were taking the rectangles and then kind of making an estimation of how much the area was, but we're using rectangles, right? So the definite integral turns out that once you have an infinite number of those rectangles, it approaches exact. And if you have infinite number, like on the left and the right, it turns out that the left and the right sum are both going to be the same as they approach infinity, because one will fill up rectangles from the left and one will fill up rectangles from the right, and eventually they'll fill in the curve. So all the definite integral is the area under the curve, exactly, and using calculus to do it. So this is, we sort of talked about this a little bit, but I don't think I gave you a name for it. So the definite integral, it gives the total change exactly. All right, so let's see, for most functions, the approximation is improved by increasing the value n. And that's what I was just saying here. It's like, if you increase the number of intervals, it means you're increasing the number of rectangles. So to find the total change exactly, we take larger and larger values. That's what I said, like going to infinity of n. Remember, n is intervals, and it's the number of triangles, or number of rectangles, sorry. And then we look at the values approached from the left and the right sums. This is kind of just saying what I just said, but this is called, by taking the limit, that means you're making more and more and more rectangles, right? So taking the limit means you're going to infinity. And because you're going to infinity, you just have more rectangles, which means it'll eventually fill in the curve. So here it says, if f, they're talking about a function, is continuous from a to b, and that means for a specific interval, right? I wonder if I have a picture of that. Yeah, see how this is an interval that's very specifically stated. That's what they're talking about here. So if it's continuous, and what does that mean, continuous? Means that there's no breaks in this. right? And it's continuous from a very specific start and a very specific end. So if it's continuous for a certain interval, the limits of the left and right sums exist and are equal. And that's sort of what I was saying earlier, like if you're doing a left-hand sum, then you would fill up the rectangles on the left side. Eventually, it would even fill in all the way in the right side because it would go to infinity. Okay, so the definite integral is the common limit of both sums. And what they're basically saying is if you did the left-hand sum and took the limit of it, it would end up being equal to the right-hand sum. And they're just talking about those different triangles, you know, like to the left when you take the left edge or to the right when you take the right edge. And we're going to do an example like that. All right, what do I want to point out here? Okay. Okay. So symbols, this, oops, need a pen. This symbol right here is called the integrand symbol. This is, I always forget the name of this. This is summa, right? You guys should know that. You're in college. Isn't that the summa? I think summa for sum. I don't know. I'm not going to write it down until I know for sure. But what I really wanted you to notice, and it says that this integrand symbol comes from an old-fashioned S, which stands for sum, in the same way that that character, I believe, is called summa, does the derivative in the integral comes from the factor t. And you may not understand that yet, but you will in a second. Okay, so this is what you need to notice here. Notice that the limits that, and when we talk about limits, we're talking about where something starts and where something ends. So notice that the limits on this symbol are 0 and -1, n minus 1 here. So this is what they're talking about. The left-hand sum, you start with 0 and then go to whatever your number of intervals are, -1. And then on the right-hand sum, this will make a lot more sense in a second. We're going to, oops, I want to show the whole thing here. For the right-hand sum, the limits are from, the limits on the integral sign are from where you start, A to B. Left-hand sum is 1 and n. That's what I want to point out to you here on this. Okay, and I'll go back to this symbol so we can go through and say, well, what does each thing exactly mean in a second. Let me give you an example. Okay, we did an example, and it was in the last set of notes, if you want to take a look at that. In the previous section 5.1, using integral, and what we want to do here is do what we did in the last example, but this time we're going to use integral notation to do it. So I didn't want to go through the whole example again, so I just brought it up again. All right, so if we said, and then also what's not in here, and I didn't notice it until later, is what we did at the very end is we said, okay, well, what if we just had 10 intervals? What would our, what would the integral be? And then we said, well, what if there were 15? And then finally, what if there were 20? But I didn't actually give the table with that because there wasn't one. So pretend that we have values. Otherwise, this example doesn't make a lot of sense. But pretend what they were saying is, what if we had more? What if we had more values for what was happening, right? What the derivative or whatever the slope. What if we had more values? Wouldn't our final integral be that much more accurate, right? So what we got, what the function itself, and I'm not giving it to you here, I should have. The function from that example was f of t is equal to 3 plus, this was given to you in that example, 0.1 t. That was the function. And then they said, well, what if we had, instead of just having like what we have here, 10, what if we had more than that? That's kind of getting your brain to say, well, you know, if we're going towards infinity with those rectangles, then that's how we can fill it in, and that's how we can get an exact answer. We don't have to estimate, right? And that's what integral calculus does. All right, so what we're doing here is we're writing the result of this table using integral notation, but this table doesn't show the other imaginary values that we had. Okay. So you would say from 0 to 20, right? So we got this 0 all the way to 20. So we want 20 intervals, and you have to pretend there's 20 values in there. Take the original function, f of t, and then the derivative. So you're going to take the original function, multiply it by the derivative, and then take the integral of that, which I'm going to show you how to do today with your calculator. So we get 0, 20, and then the function itself, which we know is 3 plus 0.1 t, and then we're going to multiply it by the derivative. And that's what your calculator will do. And what I told you is if you found the exact amount, what you would get is you would get 307 million. So in a Wiley problem, they're gonna give you a table with 20, you know, with 20 values to go with it. Is my point. I didn't want you to think they're going to give you less than you can actually use. All right, but the most important point here is how to take a table and write it out using integral notation. Everybody okay? Does that make sense? Okay. Okay, here it says to compute. Now that's different than what's the language they use? Estimate or estimate. So compute means use your calculator. Okay, so to compute this to represent it as an area, we're going to use our calculators. So what you're going to do, and I used to have a calculator on my PCPS computer, but it's gone because of the malware attack. All right, so what you're going to do is you're going to hit math. This is a TI-84 that I have, but it's probably the same menu, right? So the math menu is right underneath the green alpha button. You're going to hit the math key, and then you're going to go to and if you don't have a calculator like this, just Google it on your calculator. How can I compute an integral in my calculator? Because you will need to have to do that. All right, so you got math, and then you're going to hit something that in my TI-84, it's number 9, and it says FNINT. It's like the function integral. So you hit that key, that's number 9 for me, and then you're going to get something. Oh, I got to clear this out. That looks like this. Let's see, where's my camera? So it just gives you places to plug in the information. So let's do it. So we've got this 0 to 1. So here's what we call the lower bound. This is the upper bound. And then we're going to put the original function in, which is e to the negative t squared. And then this dt is already in, oh, sorry, I shouldn't say that. This in your calculator, even though our variable is I should get that. Even though our variable is t, you're going to use x. And then here, you're going to put x. So if you're just telling your calculator that you want it to do the integral with respect to the x variable. So let's see, I'm going to do that. 0, 1, second e to the negative 2 power E to the X, what am I doing? Sorry. Now E to the X, negative X squared. Dx. So what'd you guys get?
0.7468.
Yep, that is correct. Thank you. So it's 0.7468 and a bunch of other numbers after that. Pay attention on Wiley to what they want you to round to, okay? Like the nearest fourth place, or sometimes they'll say the nearest 10th or the nearest 100th or the nearest 1,000th. That could be frustrating. So write a note to yourself. Pay attention to what I'm supposed to round to. And then here in your notes, here's a TI-83, the directions, and here's a TI-84. So here's that number 9 function that I was doing in here. And here it says instead of a T, put an X next to the D because it is with respect to that variable. Okay, so sometimes your homework problems will ask you to compute. Compute means use your calculator, and sometimes it will ask you to estimate. That's what we're going to do in the next example. Any questions, guys? Everybody okay? I think it's happy hour for me after this. It's been a long day. You guys have other classes after this? Yeah? Oh, gosh. Well, I guess it's better than having classes really early in the morning. Anybody have like a bio lab super early in the morning? I remember that when I was in college. That was horrible. All right. So what we're going to do is to estimate this, since notice that they just say f of t. So we don't have a function, right? So like that last example, we had f of x. We had an actual function that we could put in our calculator. So it makes sense that they're asking us to estimate here because we don't have a function. We don't know what the function is. We just have numbers. And I guess you could do regression or come up with some sort of function, which would be interesting to do that. But we don't definitely do that in this class. Okay. So what we're going to do is we're going to do a left-hand sum and a right-hand sum, and then get an even better estimate than that. And I'll ask you, is it an overestimation or underestimation? So think about that as we're doing it, okay? So a left-hand sum would include all of these, right? And a right-hand sum would be, I'm going to do a different color, would be all of these values. Okay, so what you're going to do for the left-hand sum is you're going to take f of 20, whatever f of 20 is, and multiply it by what number? What's the change in t?
Two.
Thank you. Then we'll go, oops, not 20 again, sorry. 22. That should have been at 22. And then what do you guys think next? F of what? What will come after 22, guys? Come on.
24.
Yeah, thank you. 24. And then after 24, 26. Everybody see where I'm getting this, right? And all the way to f of 28 times 2. Okay, so what is f of 20? If you have an input of 20, what's the output?
Five.
Thank you. So f of 20 is just 5. What's f of 22?
7,
Good. What's f of 24?
11,
And f of 26? Somebody new. Come on, guys. I just want to know you know what I'm doing here.
18.
18,
Thank you. And f of 28 is, everybody?
29,
29,
Oops. Nope, I did not. 29 times 2. All right, you add all these up and you're going to get 140. So I want you to look at the table. Look at the table. Is 140 going to be an overestimate or an underestimate? Do you think? Just looking at the table.
under,
Say it again.
under,
Under, definitely, right? And if you just look at what I circled in red, 29, 18, 11, 7, and 5 are all smaller than 45, right? If I do the same thing that I just did on the right-hand side, I'm going to get an overestimate, right? All right, so let's do the same thing we did with the left-hand sum with the right-hand sum. So let's see. We're going to start with f of what? Times 2.
22.
Yes, right? Because that's the smallest number that I'm concerned with, that what I circled there, right? So f of 22, and then f of 24, and so on, right? And if you do that, you will get, is this going to be over or under?
Over.
Yeah. So is the number that I'm going to get when I do all that calculation, is that going to be bigger than 140 or smaller?
Bigger.
Definitely, right? So 220. All right, so then you could do the work underneath that too, like f of 27 is 7 and f of 24 is 11. You obviously don't have to write all this down when you're doing work in Wiley. I just want you to understand where I'm getting numbers. F of 26 is 18 and f of 28 is 29. So you get 220. And how could we get a better estimate based on what we did yesterday? What could we do with those two numbers to get an even better estimate?
Can you take the average?
Yes, sir. You take the average. So we've got 140 plus 220 and divide it by 2. So when you do that, you get 180. And just note that the reason why they're asking you to estimate the integral is because they're not giving you a function here, right? So pay attention to the directions, estimation, and usually if they're asking you to estimate it, they're not going to give you a function. Okay, now what we're going to do is we're going to graph our results here. And one is going to be a left-hand sum. What color did I use again? So we'll do left-hand sum here. Psychedelic. And then we'll do the right-hand sum next. Okay, so the direction R is to use this graph instead of a table this time, use the graph to estimate it. Okay, so left-hand sum, we'll start out with f of 0. And you're going to multiply it by 2. And then you'll do, and I'll show you this on the graph in a second. And f of 2, and multiply that by 2. And then f of 4. And so on. No, and that's it. Now, let me show you what rectangles go with this. So this f of 0 rectangle refers to, remember, left-hand sum is you're talking about the left edge hitting the graph, right? So the rectangle that goes with that for that interval of 2 would be this rectangle right here. So tell me, what is f of 0 according to the table? Think about it like this. When x is 0, what's y?
20.
Yeah, it's 20, right? Because you're interested in, well, actually, technically speaking, let me erase this so you can see it's not exactly 20. It's a bit over 20. Bye, John. Enjoy. See how it's just a little bit above? So I'm going to say it's like 21. All right, now let's do f of 2. So the rectangle that goes with f of 2, remember, we're interested in the left edge touching the graph, right? So the rectangle that goes with that is that. Well, actually, it's a little bit higher than that. So if you put 2 into this function, what are you getting out approximately?
About like 11.
Yeah, exactly. So does everybody see where I'm getting these numbers? All right, and then let's see, so that's 11 times 2, and then f of 4 would refer to this rectangle right here. So what's f of 4?
Five.
Yeah, 5, definitely. So this is the part where I said it's not complicated or even confusing. It's just precise. So if something's not exactly on the grid line, don't say that. They're going to give you a margin of error, but like this where it hits above that 10 mark, it's definitely not, don't write 10. Okay, write something above 10. Okay, so that's the left-hand sum. And then the right-hand sum, what are you seeing? Remember, now we're starting here. So the right-hand sum has the right edge of the rectangle hitting the graph. So here's your rectangle here. So, and we're going to start not in the first interval, but the second one, just because that's the definition of taking a right-hand sum, right? So we're going to say f of 2 this time times 2 plus f of 4, the next interval, times 2 plus f of 6 times 2. All right, so what is f of 2?
$11.
Yeah, definitely. And we kind of knew that, well, we did know that from the other one. F of 4, so now we're talking about this rectangle, is 5, right? And we know that from the other left-hand sum. And f of 6, we're referring to this rectangle. Oops, that's all right. We're referring to this rectangle. So that's about what? F of what? What would you guess? It's not 5, right? It's somewhere between 0 and 5. So I think,
2.5.
yeah, 2.5, or we can even use whole numbers. Let's say 3. Oh, and I didn't fix the right-hand side. So f of 4 is 5 times 2, and you add all that up. Sorry, I meant to finish that. You get a number. So let's look at the graphs. Is this going to be an overestimation or underestimation? Just by looking at the graphs of the actual area. Looking at this graph.
Over.
Definitely, right? This will be an overestimate. So that turns out to be 74. And if you add all this up, you'll get 38. And then, of course, like we said in the last example, to get an even better estimate, what you're going to do is take the average. But now let me show you an integral notation. Better estimate of the integral from 0 to 6 of this function, f of x dx, is about equal to, right? You can't say it's equal to because you don't know the function. Would just be our 74 plus 38 divided by 2. And that is 5.2. See some people writing. Let me give you a sec. Okay, everybody ready? All right, 5.2. Where are you? 5.3. There we go. All right, last section. Woo woo. Okay, so all along now, the calculus books sometimes like to, keep you in the dark, like what it, about its relationship to area. But I think I've brought you along all along, getting you ready to know that those rectangles eventually end up as area. Okay, so this section is all about the relationship between the definite integral and area. Basically, the definite integral is equal to the area under the curve between a certain interval, right? And that's what they're saying here. So when the function is positive, and I'll tell you what it looks like when a function is not positive, and your a value is less than your b value. In other words, this is the left side of the interval, and this is the right side of the interval. Then the area under the graph is equal to the integral. It's the same thing. Okay, so this is just reiterating kind of what I've said in the past, right? Here's an area of rectangles that will give you an estimation of the area under the curve, right? And this is a definite integral giving you the area that it's equal to, not an approximation, right? So this would be, here you're going to use, this is a computation. That's how you'd get the actual area. Where this would be more like an estimation. Like I said before, as we add more and more rectangles with smaller and smaller widths, we get a better approximation. And if we take this to a limit of accumulating infinite rectangles, we'll get the definite integral. So this is equal. Exact. Okay, so here it says, here's where they talk about things being positive and negative integrals. The graph lies below the x-axis, then each value of f of x is negative, so that's negative. Let me explain it to you in real life. Here, if we're looking for the answer to this question, it's only interested in this is a parabola, right? This is like this parabola. It's only interested in the area of the actual curve. And notice that this particular curve here is all positive. Right? It would be different if I was asking you for a different interval, like let's say from 0 to 1, then that would be a negative integral. But I have another example to show you for that. So here, what we want to say is that the parabola is above the x-axis between the two parameters here. X is equal to 1 and x is equal to 2, these. So what we can say that the integral between 1 and 2 of x squared minus 1 dx is equal to the area. And if you put this in your calculator, if you put that x squared minus 1 in your calculator and put the parameters, from 1 to 2, it would give you the exact area, 1.33, as a positive. Well, let's take a look at what happens when we have negative integrals. Everybody ready? All right. So here, this is the same parabola that we were just looking at, and there's asking you for the integral between -1 and +1. And notice that in this one, it's negative, right? It's when you get the answer to this, it's gonna be a negative answer. So in this case, and this is kind of a coincidence, but the area between -1 and 1 is really not, because a parabola is symmetrical. But in this case, we're going to get not +1.3, but -1.33. So it might surprise you sometimes, like, how can you get negative integrals? Well, now you know, because sometimes the graph will travel in negative territory, below the x-axis. Okay, now what you should be asking yourself is, what if you have a graph in an interval that you're interested in that has both negative and positive, right? So you do kind of what you would think you would do. So let's take one example. Let's say we had from 0 to 2.38. So that would be this area. Is that positive or negative? Everybody, come on.
Positive.
Yeah, definitely, right? Because it's above the x-axis. So you have x cubed minus 7x squared plus 11x dx. And if you put that in your calculator, you'd get positive 7.72. Let's look at a different interval on the same graph. What if we had from 238 to 4? Is that positive or negative?
Negative.
Yeah, right? That would be this part right here. Okay, and then I'm sure you were expecting this last question. What happens when I ask from 0 to 4? What's it going to be? Do you think it's going to be negative or positive? You could take a guess. It's sort of an analytical question. If you look at the graph, do you think the final result will be negative or positive?
Negative,
Why do you say negative?
just because it ends at negative.
It's actually positive. Why do you think it's positive? I appreciate you participating though, Tom, I really do. And it makes me feel good that you feel comfortable to just do that. That's great, thank you. So it's positive. Why do you think the final result is going to be positive? Look at the graph.
If you subtract the first area from the second area, you get a positive number.
Definitely, right? Or you could say that the first integral we did, A1, is more positive than the second interval we did, right, of A2. So you can kind of just look at the graph and say, okay, the result of adding those two together is going to be more positive than negative, right? And I want to show you this example before I show you that complicated word. All right, so this would add up to, oh wait, actually, let me get the A2 together. If you did this, you'd get negative 5.05. We were expecting that because the whole thing is negative over the whole interval they're asking you for. In A3, what you're going to do is you're going to take 7.72 and add it to negative 5.05. Which is equal to 2.67. And you can kind of even eyeball that and say, yeah, that would be a positive number because one part of the graph is more positive than the other. Okay, now notice what I'm asking you here very specifically, right? I'm asking you for the integral of this function, right? So that would be a positive, that would be a negative. This next example, you guys need a minute to write? I can wait. All set? Okay. You guys should tell me to slow down. You know, I get all excited about the math and then my students in high school always say, Ms. Halderman, slow down. All right, example 3. Now this is a different question. Beware, be careful. Okay, I know you guys are gonna make this mistake and you're gonna wanna meet with me and say, what's going on here? What they want is the total area, okay? Now area, if they're asking you for the area of a circle, right? You don't care whether the circle is above or below the x-axis, right? You're gonna give the area of all the shaded region, right? So we're talking about the area here plus the area here. And just because it's negative area, you're not gonna put it as like this would be more positive than negative or whatever, right? So if they ask you for the total area, A1 we said was 7.72 and A2 we said was negative 5.05. Just be careful here that you're taking the absolute value of a negative number, right? Because it's like if they asked you to compute the area of the shaded region in a geometry question, right? You're not going to subtract one from the other. So here you'll get positive 12.77. So careful, those are two different questions. If they ask you for total area, you're going to have to change the sign, right? And just take the absolute value of the negative area. And that's with the word total area. Okay, almost done. Any questions so far? I told you this stuff wasn't too difficult, which I always love to end on something that's not like crazy hard for students. All right, cool. Oh, let me move this down. Okay, so take a minute for each of the functions graph, decide whether the interval from 0 to 5 is positive, negative, or maybe 0, approximately 0. What do you think? What do you think about A? We're talking about so we want to know, is it positive, negative, or approximately 0?
Negative.
Yeah, this is negative. And we're asking you back, remember, we're not asking you for total area. We're asking you about the interval from 0 to 5. So what do you think about B? Here's the positive area, here's the negative area. Is this going to be positive or negative?
Positive,
Yeah, definitely. And tell me why.
because there's more positive area than negative.
That's exactly right. Very good. Thank you, Drew. And what do you think about C?
Would that be 0?
Yeah, it'd be approximately 0. I mean, hard to tell, right, without the actual numbers. But both of the areas, the positive and the negative areas, would cancel each other out, right? So you could say it's approximately 0. All right. Now we're going to go on to the area between two curves. So if you wanted to find the area between this f of x and g of x, what you could do is just subtract those in the integral. So here's the formula, right? If you want to tell what this area is equal to, you're just going to take the integral of f of x, that's the one on top, subtracted by g of x. And they do tell you that if f and g are continuous functions and g of x is less than f of x, right? G of x is underneath f of x. For that interval a, b, obviously a is smaller than b. Then all you have to do is subtract. So here's an example. Notice that f of x is on top and g of x is on the bottom, and they're interested in this shaded area. So you can do the interval notation here, integral notation, 0 to 3.12 is equal to, or actually is computed by 4x minus x squared minus 1/2 x to the 3/2 power. So what we have here is we have f of x minus g of x. So what do you guys get? Somebody compute that for me using your calculator. You notice I'm using extra parentheses, and that's because let's say you were doing it the other way. You were taking 1/2 x to the 3/2 and subtracting 4x minus x squared. You have to be careful because you're not just subtracting 4x, right? You're also subtracting negative x squared. So I've always put double parentheses around everything so that I don't ever have to worry about PEMDAS or distributing a minus sign across two different terms. In this case, you probably wouldn't need it. So we're talking about this area right here. Is this going to be a positive number or negative number, do you think? What do you guys think? Come on, before you even compute it, what do you think? Is it going to be positive or negative?
Positive.
Yeah, why do you think it's going to be positive?
Positive. Part of the graph is larger.
Yeah, well, one thing you can say is that the entire graph is above the x-axis, right? The entire shaded region is above the x-axis. So the whole thing's going to be positive, right? There's no negative territory to the graph, so we don't even have to worry about comparing different areas. Anybody have a number for me?
5.906.
Awesome. Correct. Good job. And did you use the double parentheses like I did? I don't think in this case you would need it, but I always put it in just so I don't make a mistake. Thanks, Zach. Perfect. All right, guys, that's all I have for you. Do your homework right now. I'm letting you out again 15 minutes early. You can probably get it done in 15 minutes because it's really right there in your head, right? Use the last 15 minutes to get that Wiley work done. All right. All right, we're done. Isn't that weird? So the next class I'll review with you for the chapter 4 and 5 test, and then we'll take the test, and then we'll review for the final exam, and then we'll take the final exam. Hey, I had a question for you guys. Your final exam is scheduled, but I think since all final exams are online, if we all agree to change the date, we can. How do you guys feel about that? Right now, let me tell you when it's scheduled. It's scheduled for Wednesday, May 12th, and your final exam is on May 3rd, which is concerning for me because I would rather give you your exam sooner. I mean, that's 9 days away from our review. What do you guys think?
Wait, so you're saying that our final exam is scheduled for May 12th or May 3rd?
May 12th.
Okay, and you would like us to reschedule it?
Well, my concern is that I'll do the final exam review, and then 9 days later, you take your final exam. That's a long time. How about this? We have a couple weeks to decide. Can you guys figure out your exam schedule for other classes? And maybe we can come up with something that is more advantageous for you guys. But if the other hand, if you look at your exam schedule and you say, hell no, I'm going to be studying for this other test that I have in physics or whatever. And no, I could use the extra time to wait to study for math or whatever. But that was just, when I looked at the date, that was my concern. I just think 9 days is a long time for you guys to wait. But those days I'd be available to help you too. So it's up to you. Why don't you guys think about it and look at your schedules, okay? We don't have to change it. Giselle, you have a question, honey?
Yeah, I was just wondering if we could switch the review day a little bit earlier, later or something like that.
That's something I'm willing to do, sure. The only problem is that people might have exams scheduled for that time. But why don't you guys all check your exam schedule, see if you can get when you're having which exam, and then let's talk about it next time. I'm totally open to whatever is best for you guys, including having it where it is. I just thought I'd bring it. That was my concern. I was just a little worried about you taking the test, 9 days after we have our last day of class, something like that. But check your schedules and we'll talk about it next class, okay? That's all I have for you. Dylan, you're still here, right? Where are you?
Yes.
Okay, cool, because we need to talk. All right, guys, if you guys need to talk to me or get together with me or get some extra help, just, email me or text me. Text me is always great because that email that I gave you, the email address, doesn't come up on my phone because of the malware, when we got invaded or whatever. So I always have my phone with me, but sometimes I have to sit down at my computer to get those emails from you guys. So texting is always better, faster results, okay? All right, you guys can.
Can you make the test accessible? Exam 2.
I'm not.
So I can see. So I can review it.
Test chapter 2 and 3. You mean?
Yeah, the most recent test.
Maybe I
can't see what I got wrong.
Yeah, let me see if I can do that. It may not be the problems that you had, but yeah, I'll do that. And that's for if I do it for you, I'll do it for everybody.
Thank you.
You're welcome. All right, you guys are free to go.
Thank you.
Just got one quick question about the
go
extra
for it.
credit. You wanted us to email it to you to your Baltimore County account, right?
Yes.
Okay, that's all.
Okay.
All right, have a good weekend.
Bye, Tom. Thanks. You too,
Bye.
sweetie.
I have a quick question.
Yes, Jadelle, how are you doing, honey?
I'm okay. How are you?
I'm good, I'm good.
Um, I know I can search this up on Google, but it's not coming up for my calculator. So every time I search it up, I don't know if you can see it, but like the integral doesn't have like the bottom or
What
up
kind of
rating.
calculator is it?
It's a Casio.
Casio what?
FX 9750.
Hang on a second, Dylan, I'll be right with you.
Okay.
There's a video here on how to
Okay.
do it.
Yeah, then I probably just searched up the wrong thing. Okay,
Yeah,
thank you.
do Casio, all I did is I said Casio FX 9750 integral.
Okay,
And there's a video that comes up. It's only 2 minutes long, so
okay, thank you.
you're welcome. Let me know if you have trouble, because I can definitely help you with that.
All right, thank
All
you.
right, bye, sweetie. Have a great day.
You too, thank you.
Thank you. All right, Dylan, what's up?
Hi,
Did you
Professor.
do your- did you do your test?
I
Yeah,
did do my test and I did not do very well. I'm just like not grasping this content for some reason. I don't know why. I'm like actually really trying, and I just like
do you know
can't.
what your current grade is?
Not great.
What is it? You know it. I actually, it doesn't even show me. I mean,
On Wiley,
I would have to actually calculate your grade to know what it is. I know that you have low scores, but I don't
Yeah.
know the actual grade. What is your actual grade?
so let me do the math real quick.
Did you do your extra credit?
Now, I was also going to talk to you about that. So I have a 52 right now, which is obviously not where I want to be. The extra credit, I just saw it like yesterday, like right before I was about to go to bed.
Go ahead and do the extra credit and send it to me.
Okay. Because like back in high school, like calculus and math in general for me was just like very difficult. And the only way that I would squeak by is I would go to like our math resource center every day after school and just like sit there for hours with teachers just working
I'm
on it.
sorry, that sucks. And I know some people are just, just really have a hard time with it.
Yeah.
I don't know what I can do for you other than that, take advantage of the extra credit. That's a good amount of points. And, you're not completely sunk yet because you still have another test to take and your final exam is worth a lot, But is there a resource center there that you can go to? Isn't there a math lab?
I know there's tutors, and I've tried it before. And just like for me, online tutoring is just like so much more difficult. Like for me, I like to have somebody there that can actually like physically show me. And it's just like so hard over Zoom. But
Yeah, I
just-
know. I worked with kids in high school like that. I'm sorry.
yeah,
But
it's okay.
hopefully this is the last math class you have to take, right? 'Cause
Yeah, well,
you're
I was
business,
gonna,
right?
yeah, I was gonna do accounting, but now I'm starting to reconsider because it's just the numbers are not, it's a lot. But yeah.
Like
So I also
business
have,
administration or even business management. I mean, you're a very personable guy. You'd probably do great in marketing or.
yeah, I think I'm starting to think I might do marketing, but I just like my whole family is accountants, and that was like the thing I always wanted to do. But now I'm just like not the numbers.
Yeah,
just
yeah.
But
Well, I'll do whatever I can to help you. I mean, and if you need help with the homework or whatever, your grade, everything you get from this point forward needs to be good.
yeah,
You know,
okay.
to pass the class and do the extra credit. Okay, and can you get that to me by midnight?
Yes, I can. I'll do that. And there's also some homework assignments that I'm still kind of like I haven't even done all the questions just because I really am not like grasping it, and I don't want to completely mess it up before like my time or my times I can do it is run out.
Okay, so is your time out on any of them?
My time is out on a few of them, but the questions aren't like completed. You know what I mean? So it's like I haven't gone through all three of my tries.
Oh, but the time is out, so I need to to set it up to let you in again?
Yeah, I
I
believe
need
so.
to know, I need to know which ones those are.
Okay, the ones
I'm
are,
gonna make a list right now. Just tell me.
okay, it's 4.2, 4.3, 4.7, and 4.8.
All right, when can you get those done, you think?
I can get those done.
We're gonna do the extra credit today, so I don't want to say today, but
Okay, I can probably get those done by Friday at midnight.
okay,
If that's
deal.
okay.
Yep.
Okay, so I'm gonna try and see if I can get a tutor by then, just to kind of like a student tutor, maybe see if I can meet up with them.
Well, let's give you till, you gonna be partying all weekend or are you working a little?
Um, I mean, I have to work this weekend too, so I'm gonna have a pretty big weekend. But
So Friday is good for you?
yeah, Friday should be fine. I mean,
Well,
I
I'm
just
gonna give you a little more time, but you're working all weekend. It's not like you'll be doing any work this weekend.
yeah, I mean, I don't work Friday, but I know that I have a,
All right, so let's say Friday midnight. I'm gonna set that right now, okay?
okay, yeah, Friday midnight's fine.
All right, have a good weekend.
Thank you so much. I appreciate it.
Of course.
All right, have a good one. Bye.
All right, thanks, bye.